Okay, in this session we're going to have a look at angles and angle measures, part 1, from Unit 4, Chapter 4, Trigonometry in the Unit Circle. In this lesson we're going to focus on a couple of things. We're going to focus on sketching angles in standard position, measured in both degrees and radians. We're going to learn how to convert angles in degree measure to radian measure and vice versa. We're going to have a look at positive and negative angles of rotation. Okay, let's quickly review what a radian measure is. First of all, we need to realize that angles can be measured in both degrees and radians. A radian is simply this. One radian is the measure of the central angle subtended in a circle by an arc equal in length to the radius of the circle. If you look at this diagram, it gives you some idea of what a radian measure is. When the radius is equal to the measure of the arc for this central angle, when the radius is equal to the measure of the arc, then the measure of that angle is 1 radian. An angle measured in radians is equal to the arc length divided by the radius. Using this simple formula here, let's go over and determine how many radians are in one full revolution around a circle. So 360 degrees is one complete revolution, is equal to the arc length divided by the radius. The arc length of a complete revolution is equal to the circumference of the circle divided by the radius. Circumference of the circle, of course, is 2 pi r. Divided by r equals 2 pi. So we have one complete revolution, or 360 degrees, is equal to 2 pi. Using this simple fact that 360 degrees is equal to 2 pi, we can easily determine some other angles in radian measure. If one revolution equals 2 pi, then a half a revolution, or 180 degrees, is equal to pi. 1/4 of a revolution, or 90 degrees, is equal to pi over 2, and 45 degrees is pi over 4. Many of these you need to memorize. 90 degrees is pi over 2, 45 is pi over 4, 180 is pi, 360 is 2 pi. If you want to change from degrees to radians, we need to figure out how many radians is in 1 degree. So if 180 degrees is equal to pi radians, if we divide both sides by 180, we get 1 degree is equal to pi over 180 radians. In a similar way, if pi radians is equal to 180 degrees, if we divide both sides by pi, we get 1 radian is equal to 180 divided by pi. Using this information, we can easily convert from degrees to radians and vice versa. Let's have a look at some of these. Converting from degrees to radians, what you simply need to do is take the measure of the angle in degrees and multiply by pi over 180. Because as you just saw in the last slide, that 1 degree is equal to pi over 180 radians, so 30 degrees will be 30 times pi over 180. 30 times pi over 180 is equal to pi over 6 radians. And we do the exact same thing with the other angles here measured in degrees. 45 degrees, I simply multiply by pi over 180. And when I reduce my 45 over 180, I will get pi over 4. So 45 degrees is equal to pi over 4 radians. 60 degrees, in a similar way, 60 times pi over 180. Let's reduce the 60 into 180 to get 1 over 3. 60 degrees is equal to pi over 3 radians. We can also convert from radians to degrees, but when we do that, now we multiply by 180 over pi. And for the reason given back here, the fact that 1 radian is equal to 180 over pi degrees. So to change from radians to degrees, we multiply by 180 over pi. The pi's cancel, and they will always cancel when changing from radians to degrees. So I simply do 2 times 180 divided by 3, which is equal to 120 degrees. So I quickly changed radians to degrees. 11 pi over 6, same thing. 11 pi over 6, I simply multiply by 180 over pi. The pi's cancel. I get 11 times 180 divided by 6. That's going to give me an answer of 330 degrees. 330 degrees. Last one here, 5 pi over 4. I simply again multiply by 180 over pi. The pi's will cancel. I get 5 times 180 divided by 4, which will give me an answer of 225 degrees. 225. That's a very quick and simple way to change from any degree measure to radian measure, or vice versa, from radians to degrees. Just remember that you multiply by pi over 180 when you're changing from degrees to radians, and if you're changing from radians to degrees, you multiply by 180 over pi. Okay, let's have a look at a couple of other things here. First of all, positive angles are always measured in a counterclockwise direction, and they will always be measured from the positive x-axis. All angles are measured from the positive x-axis right here. This is a positive angle of rotation, 30 degrees. A negative angle of rotation is an angle measured again from the positive x-axis, but is measured in the in the clockwise direction. This one is the counterclockwise direction. This one is the clockwise direction. So negative angles are measured in the clockwise direction, as you can see here. Here's my terminal arm. Here's the initial arm. The initial arm. All of these angles are always measured from the positive x-axis. An angle in standard position is simply an angle that has its center at the origin and its initial arm along the positive x-axis. So both of these are angles in standard position because, again, it has its initial arm along the positive x-axis, and this is the terminal arm here. We just saw that this is a positive angle of rotation. This is a negative angle of rotation, as you can see, about a negative 120 degrees. So that's an angle in standard position, always measured from the positive x-axis. Let's have a look at some examples quickly here. What is this rotation in standard position? The measure of the angle in standard position. You can see here that the angle given is this 30-degree angle right here, which is really a reference angle. We know that this is 180 degrees. So therefore, the measure of the angle is going to be 180 minus 30, which is 150. Now, that's 150 degrees. We need to be able to change that to radian measure. So we multiply by pi over 180, and that's going to give me 150 pi over 180. When I reduce that, I'm going to get 5 pi over 6. 5 pi over 6. Answer is D. Example 2, you may want to pause the recording at any time. You might want to remember that. You can pause the recording at any time and maybe try some of these multiple choice on your own before I actually do them. Might be a good idea to do that now. Example 2, what is the measure of this rotation in standard position? Very similar to the last one, but now it's in radian measure. The measure of this angle is given in radians. It's pi over 3. Notice that it's a negative angle of rotation because your angle is measured from the positive x-axis in the clockwise direction. So this is a negative angle of rotation. So we automatically know the answer either has to be A or B because of the fact that it's a negative angle of rotation. Pi over 3, if you want to do it in degrees or radians, it doesn't really matter, I suppose. But pi over 3 is 60 degrees. One that I've memorized, and you should memorize it as well. So if that's 60 degrees here, then this angle here again must be 180 minus 60, which of course is 120. And of course we are looking at a negative angle of rotation, so it's negative 120 degrees. So negative 120, change that to radian measure, multiply by pi over 180, and we will get negative 2 pi over 3. If I reduce, I'll get negative 2 pi over 3. Correct answer is B. What is 468 degrees in radian measure? This one now we have to change from degrees to radians. 468 from degrees to radians. We multiply by pi over 180. 468 pi over 180. All we need to do is reduce this. So let's see what we're going to get here. I think each of them are probably divisible by 36. So if I were to take 468 divided by 36, I will get 13 pi. If I were to take 180 divided by 36, I will get 5. So I got 13 pi over 5. Correct answer is B. Okay, example 4. Draw each angle in standard position, change each degree measure to radian measure, and change each radian measure to degree measure, and give answers as both exact and approximate measures, if necessary, to the nearest hundredth of a unit. Okay, let's draw the angle in standard position first. An angle of 30 degrees is a positive angle of rotation. Remember, we're always measuring from the positive x-axis. So an angle of 30 degrees in the positive x-axis will look something like this. So there's my angle. I need to change that degree measure to radian measure. So I simply multiply by pi over 180. And that will give me pi over 6. Now it does say give the answer as exact and approximate measures if necessary. We can give it as an exact answer, so we'll leave it as an exact answer. Let's have a look at B. Negative 120 degrees. Let's draw the angle in standard position. First of all, angle in standard position. Always measuring the positive x-axis, as I said. Negative 120 is going to look something like this. Rotating in the negative direction. Negative 120, let's change it to radian measure by multiplying by pi over 180. Which is going to give me negative 120 pi over 180. When I reduce that, I get negative 2 pi over 3. Let me just move this down here a little bit so that's out of the way. And let's do C. 5 pi over 4. Now, the first thing we might want to do here is change this to degrees for plotting our angle in standard position. So let's multiply this by 180 over pi. Pi's will cancel again. And I get 5 times 180. Let me fix that. So I get 5 times 180 divided by 4, which will give me, let me grab my calculator here, 5 times 180 divided by 4 is 225. So I'm trying to draw an angle in standard position of positive 225 degrees. Positive 225 looks like this. Rotating in the positive direction. 225 is approximately here. Which of course is 5 pi over 4. 5 pi over 4. And finally D, 2.57 radians. The word radians is not written there, but we have to assume that is radians because there's no degree symbol. And again, we need to sketch the angle in standard position. Let's find out what it is in degrees first. So we're going to multiply this by, if we're changing from radians to degrees, we multiply by 180 over pi. Now notice this time, the pi's cannot cancel. There is no pi in your radian measure, so we simply need to do this. 2.57 times 180 divided by pi. And we use our pi symbol on our calculator. 2.57 times 180 divided by, and I'm dividing by pi, and I get approximately 147 degrees. It's actually 147.2 degrees. So again, if I want to sketch that angle in standard position, approximately 147 degrees would be somewhere around here, I guess. Somewhere around there. And again, that's in the positive direction. So that's approximately 2.57 radians right there, 2.57 radians. So the key thing here is changing from radians to degrees and vice versa. And knowing, of course, positive angles versus negative angles of rotation. Key ideas: angles can be measured using different units, including degrees and radians, which we've already seen. An angle measured in one unit can be converted to the other unit using a relationship. 1 full revolution, or 360 degrees, is equal to 2 pi, and we've already changed the number of them today. An angle in standard position has its vertex at the origin and its initial arm along the positive x-axis. That's an angle in standard position. And angles that are coterminal have the same initial arm and the same terminal arm. We're going to be doing more work on coterminal angles in an upcoming recording. That ends this lesson.